Okay, I'm going to have to ask my editor next to me just to flip to the next slide. Okay, so the key discussion points: introduction, the importance of trommel screens, trommel screen mill applications, the sizing. We're not going to go into too much detail there. What information is required to size a trommel screen capacity, and the sag trommel size example. We're going to look at the difference between ball mill trommels and sag trommels. Trommel screen rotation, trommel screen design, members of the milling circuit, and then trommel screens versus vibrating screens. Okay, so my first picture here, you will all recognize that's a typical car crash where they look at the safety and then the structural damage to the vehicle. So what we do, once we've designed the trommel screen, there's a lot of work going into that and a lot of thinking. So how can you actually physically test the structure of, and that trommel you see there is more than 5 meters in diameter. So we fasten it onto a low bed. We look for a bridge where there's not too much traffic, and we ride or drive into that bridge at 80 kilometers per hour to see what happens to that trommel. And that's what it looks like if you've crashed into a bridge. There's another picture. Okay, so ladies and gentlemen, I'm actually just pulling your leg. That's not really what we do. That incident was caused by a traffic officer that was supposed to guide our trommel from one of the engineering places, and he did a little miscalculation on the height of the bridge. But what is very relevant is after that accident, when we checked the trommel structure, there was not one weld that was broken, and there was absolutely no failures on that trommel. And I think that is significant if we look at the design or the design we use to actually build these huge trommel screens. Okay, the importance, what is a trommel screen? It's known as a mechanical rotary screening device. Installation of a trommel screen is attached to the discharge end of a mill, and you can imagine the size of the mill. If that trommel has got a diameter of 5 meters, the mills are huge. Removal of the oversized and worn grinding media, that is probably the most important function of that trommel screen, to protect the cyclones and also to protect your pumps. The trommels are designed in conjunction with the mill OEMs. So we initially, when there's a new project, we work with them to see or look at the configuration of the mill before we design the trommel screen itself. And we have over the last 30 years done more than 1,000 installations worldwide. Mill trommel applications: ball mill, sag mills, rod mills, and ag mills. Okay, the capacity, if you look at the trommel screen, the surface that's actually being used, it uses between 25 to 30%. So the capacity is a function of the slurry density, aperture size, and the open area. The drain rates range from 450 to 1,000 cubic meters per hour per square meter. And that will be determined by the type of panel you use, the density of the material, etc., the size and the shape of the material. This is a typical example of one of our sizing calculations. You can see the trunnion, flange, ID, OD, PCD, very important, the feed to the trommel, the tonnage, including the circulation load, the solids density, pulp SG. Then we look at the total pulp, in this case 1,194 cubic meters per hour at 70% solids, which is quite normal. Screen panels, that will be determined by, is it going to be a ball mill trommel, sag mill trommel, thickness we require, configuration of the weir bars, etc. Aperture size, 12 by 50 is a fairly common aperture that we use, and that's got more or less a 30.6% open area. Okay, so we get installations where there are 2 mills next to each other, and each of them will rotate in the opposite direction. We also refer to some of these mills as bidirectional mills, so you can start them on a clockwise or anti-clockwise direction, and then we will use specific weir bar configurations for bidirectional mill. But the rotational direction of the mill is very important because your weir bars will be designed according to that clockwise or anti-clockwise direction. Right, the design, fine element analysis is what we typically use. It's designed on 10 million cycles to give us a good indication of the strength of the various areas on the trommel screen. We typically design them or try and design them to be a 1-to-1 ratio, so diameter to length. Otherwise, the longer the trommel, then you will get that cantilever effect and it will put a lot of strain on the flange, and you've got to then obviously compensate within your design for that. 10 to 28 panels in circumference to be modular trommel design, 30 panels and more to be a shell plate trommel design. Just a picture of an installation on sag mills. Okay, so the elements within the milling circuit, and Aris is going to touch on the cyclone part in the next presentation. The mill, trommel, pebble crusher, cyclone samplers, pump, they all form part of this heart of this operation. And for myself, the most important thing is the structural integrity of that trommel. I don't think any plant manager wants to buy a cheapo somewhere and then have sleepless nights wondering when that trommel might break off and he might have to stop that plant. And you can imagine, if we look at the current gold price, you would certainly not like to stop your mill for a couple of hours and you're not benefiting from the current gold price. So the same as on iron ore, when you're busy milling magnetite, and you're treating a lot of tons, if you had to stop that plant, you are going to lose a lot of money per hour. And you don't build a trommel overnight. The lead times are anything between 16 and 24 weeks, depending on the size. So can you afford it? Definitely not. You cannot sacrifice on the structural integrity of that trommel screen. Right, we're going to distinguish now between the sag and ball mills. The approach is distinctly different. Two main areas influence are the screen meter and the retention systems. So on the ball mill, screen media, typically we grind smaller than 75 micron. Scats define the lump size. It's usually less than 5%, the oversize going over the trommel screen. We do not overlook PU, cost and lead time benefit. Wide range of SIP slots into pin apertures available. Dose flotation, so leach reagents, things like that will determine the specific type of material that we use. Molds and insert fraction of the cost. You'll see it varies significantly from the sag mill designs. In case of large shell plate ball mill trommels. Okay, the weir bar and scroll design. The scrolls typically we use 1.5 to 2.5 turns, depending on the retention, the drainage we acquire within the trommel screen. The grind is fine, and important here is the laminar flow in a ball mill trommel typically. The grind is fine. Sorry, let's just go back one. We do not have to cater for heavy solids loading. The weir bars and scrolls generally low in height. We can get away with fairly simple attachment methods. At the cast on units, the super scroll units that we've designed 10 years ago. Then the overflow discharge, Waldo just mentioned that in his previous presentation. Common on most ball mills, laminar discharge. The grind is fine, 95% of the solids is underflow fraction. Above allows us to spec low to medium duty panels. Fairly simple and economical weir bars and scrolls are used. Then the cast on scrolls, typically on a 30mm thick panel. Piers and blade type scrolls, these are significant of the super scrolls that we use, and they basically bolt onto the piers, which gives you a nice consistent spiral through the trommel screen length. Then on the sag mills, the screen meter, yeah, the lump size could be up to 100mm, much higher solids loading. You could have up to 15% oversize going over that screen length. Makes for a highly abrasive environment. The goal is to offer a 24-week solution at least. Compression molded rub is preferred for most duties. Panels could be up to 80mm thick. to consider deperforated or working depth panels. New designs, mold and insert cost is going to be a challenge, up to $25,000 for a new design. Then on the pebble ports and grater line, what's significant on this picture on the left is the shape of those particles coming through the discharge grating. And if your discharge grating, your pebble ports are worn, you will see significantly sized particles coming through there, thus increasing the wear on your trommel screen. We have actually companies that have installed steel plate designs. They have replaced them with the Multotec trommels, and based on cost, life, etc., the polyurethane or rubber type modular system proved to be the most significant or best option for those specific mills. Just another picture of the size of some of those pebbles or material coming through those ports. Okay, then the sag mill, you can see the typical configuration there of the scrolls. That could be a bidirectional mill, turning left or right. Wear-bound scroll designs, consider the nature of the mill discharge, often very turbulent on a sag mill. Lump size, pebble ports, solids loading call for structural integrity. Design wear bars and scrolls for 24-week wear life. Turbulent discharge. Wear bar and scroll lights promote laminar flow. The wear bar position in case of large step from trunnion to trommel. Model discharge trajectory. And that's significant on the very large mills where you've got quite a step from the discharge of the mill onto the trommel screen. Wear bar and scroll attachment becomes critical. Then, great discharge common on large diameter high capacity mills, lifters or pulp chambers, direct slurry to center cone of the gooseneck, and Waldo gave us a very nice description of that in the previous presentation. Yeah, we've got some schematic diagrams of the type of scroll configurations that we could mount onto the trommel screen for specific applications. Then, trommel versus vibrating screens. Trommels are simple, robust equipment, do not require specialized skills to maintain. Rotary unit makes for less downtime, and then do not require civils like vibrating screens, dynamic loads. And I think what is very important here is if you look at the surface being used, a third, 25% to 30%, like we showed earlier, that the trommel will probably last 3 times longer than a typical vibrating screen where you use the whole surface of that area. And for me, that's probably the most significant advantage for the trommel screen. Conclusion, efficient mechanical method of screening coarse particles, increased wear life. Trommel screens design reduces pegging and blinding. Depending on the type of apertures you use, the thickness of the panels, perforated thickness, etc. Enhances your screening performance. Modular screen media reduces the OPEX and downtime. And then attachment systems allow for quick and safe panel change outs. Modular system allows for support frames to be reused and refurbished if they have been protected properly, so the rubber lasted and you did not have shoots coming too close to the trommel, building up material and damaging the rubber. So we will have a specific inspection on a trommel screen if they feel that they wanted to possibly refurbish that trommel screen. We'll have to do possibly some NDT test on the flange and see if it's possible to then refurbish that specific trommel. Fine element analysis techniques ensures structural integrity.